Well, hello viewers. In this video, we are going to look at yet another project using Edison Robot. The name of this project is Mexican Wave. So for the agenda, we'll look at the project overview. What does it mean? What we are going to do in this project? What prerequisites are required for the viewers before they can understand and benefit from this project? Then we will look at the working demo of the project. And finally, we'll do some code review. This is a really nice team building exercise for the students because it requires coordination between different um, Edison robots. So the prerequisites for this project are that you have some understanding of Edison robot and how it works and how you can program the robot and how you can run the program. So you have some understanding and specifically be able to send and receive the infrared data with the robots as well as some line tracking. Then it will be also beneficial if viewers have understanding of the Python programming for the robot, though we will in this video go over the flow and the logic of the Python programs used for the Edison robots. And in general, you have to be creative if you want to manipulate and do certain things differently and not just follow the sample format that you're going to see in this video. So what this project is about. So in this project, I'll demonstrate a sample Edison robot application, and it could be based out of 2 or more Edison robots. These robots are going to synchronize their movement, and they will go back and forth between the 2 black lines, and it will follow the pattern of a Mexican wave. So before we look at how the robots are going to behave, let's look at what Mexican wave look like. So I was just searching on Google, and this is what a Mexican wave will look like. Especially it happens during like soccer games and football games. You have people who stand up after one another and creating a wave that basically goes around the stadium. And they do it in a waveform, and they follow one another until it reaches the end. And that's the same concept we are going to apply for the robot. So in our case, I'm using 3 Edison robots. Of course, you can use more if you want. So we'll start with the first robot, and it will start moving forward as long as it's on the white line. And when it reaches the black line, it's going to stop, and it will give an infrared IR signal to the send it out, and it will give the signal to the second robot. The second robot will get the signal and start tracking, and it will also reach the end of the line, and it will stop when it reaches the black line. Now you can configure the first robot however long you want it to wait. It's gonna, I think in my case, it's like 2 or 3 seconds. It's waiting towards the end of the line, and then it will start coming back. Similarly, when the second robot reaches the end of the front line, it's going to give an IR signal, infrared signal for the third robot, and the third robot will start tracking and it will reach the end of the line, and then it will also stop. So in the meanwhile, the third robot is coming back, and then it will reaches the end of the backside, the black line at the back. When it does, it will give out the second infrared signal to the second robot, and now the second robot will start coming back. When this one reaches the black line at the back, it will give the second signal to the third robot to start coming back, and the third robot will also start coming back. Meanwhile, the first robot, since it has reached the end of the line, it will start going back upwards, and this process will repeat, and the Edison robots will follow one another. But as I said, you are able to, if you want, however, you can configure how long you want it to wait and how fast they travel. You can also change the scheme with which these robots are following one another. If you want to wait before you send the signal, or you want the receiving robot to wait before it can respond to a signal. Okay. It's all up to your students how you guys want to do that.
Okay, now I'm going to demonstrate to you the working of the Mexican wave. There are three robots that I have programmed. This is the leading robot. This is the second robot is going to follow the first one. This is the third robot is going to follow the second one. I'm going to start them in the reverse order. So I'm going to start at the third one. I've started the second one. They are waiting for the signal. This third one is waiting for the signal from the second one. The second one is waiting for the signal from the first one. And I have not started the first one yet. I have only configured three robots. You can configure more if you want, but then you have to write the or change the program for the fourth, fifth, and sixth robot so that they wait for the signal from the robot before them. Also, you can configure the speed and how long you want this, especially this leading robot, to wait towards the end of the line. Because when it reaches the end of the line, it gives a signal to the second robot, and the second robot starts tracking, but it does not move. The first one does not come back after a certain time, and it waits and then it starts coming back. When it starts coming back and reaches the end of the line here, then it gives a signal to the second robot, and the second robot starts coming back. Of course, when the second robot, whether it reaches towards the end of the line on that side or this side, correspondingly gives the infrared signal to the third robot so that the third robot can start moving after the second one. Okay, so let's start the program, and I'm going to make sure that these robots stay away from one another because they have a tendency to track slightly in a different directions, not really going straight, and they run into one another. So let's do that. This is your first robot. It's reached the end of the line, gave a signal to the second one. Second one reaches the end of the line, gives a signal to the third one, and that's how it progresses. When the first one comes back, it gives the second signal, and the second robot then comes back. Then it gives a signal to the third one, and the third robot comes back. Yep. So this is the demonstration for your Mexican wave.
Now we are going to do the code review for the Edison Robot, the Mexican wave. So we have three programs. This is the leading robot, this is the second robot, and this is the third robot. So the leading one, the first follower, and the second follower, and then you can have any n number of followers for depending on your number of students, but they have to coordinate their robots with one another. All right. So what the first robot is doing is it's just going back and forth. So it is in this big while loop. And x is the direction of the motion, as 0 and 1, and it is required to know what signal to send to the second robot. So if it is on the white line, and we have to turn on the line tracker, it's on the white line. If then if s is equal to 0 means it was moving forward, it was x is equal to 0, then it will move forward. Otherwise, if x is equal to 1, it will move backward. Otherwise, if it is not on the white line, if it is on the black line, that is, it has reached the end of the line or towards the front or towards the back, what it will do, it will stop, as simple as that. That's it, nothing more, just stop the motion. And if x is equal to 0 means it was moving forward, it will give the infrared data 10. That is going to be used by the second robot. Otherwise, it will give infrared signal 20. 10 means for the other robot to move forward, and 20 means for the other robot to move backward. So this is where the coordination between the students come in. Now it's going to wait, and it's 2 seconds. You can make it wait longer or shorter, depending on however you configure your program. Then it will start driving backward, and and it will keep driving backward. Now, there's one difference over here is that I did not just start driving backward, but I'm driving about 5 centimeters backward, and then I'm doing an unlimited. That means that it drives back for 5 centimeters and then it goes unlimited. So you may ask why I've done it this way, and I think this is more critical, so I'll leave it to the viewers to basically discover. Try to remove this line and see what happens. Similarly over here, for so this was the case for when the Edison robot was moving forward and it reaches the end of the line towards the front. This is the case when the Edison robot was moving backward and it reaches the line towards the back. Again, it waits 2 seconds, sends the signal 24, let the other second robot know to start moving backward. Then it starts moving forward, but again, just like before, I am moving 5 centimeters before I start driving the robot, or before the robot start driving an unlimited for unlimited distance after it has covered this 5 centimeter. And there's a reason for that. I hope users are able to discover why I had to do it this way. Or you can try to take out this line and you will see some weird behavior that you may have to encounter, may have to fix it. So let's look at the first follower or the second robot, the one in the middle. So this one program is a little different because when it starts, it's not supposed to move. The first robot is all going to move right away in the front, towards the front. The second robot is not moving. So again, we are using this X variable and we are setting it to 3. Its main program is just this. While true, it doesn't do anything. But I have registered 2 event handlers. One is monitor infrared data, IR data, which is this function, and the other event handler is monitor line data, which is this function. So these functions are called when there's a change in the line or there's a change in the infrared data. So when there's a change in the line, and for example, here we are reading, if the read line state is on the black line, then it basically stops the Edison robot, right? If X is equal to 0, means it was again 0 forward direction, 1 backward direction, and 3 do nothing. And this is a global variable that we have defined. And that's why it's defining global X. So this is the direction, and this is that. So at this stage, the Edison robot has reached either towards the front or towards the back. If X is equal to 0, means that the Edison has reached or was driving forward, so it has reached the front line. If X is equal to 1, means the Edison has reached the backward line. So when it has reached the front line, it gives out 30 and 40. 30 is a signal to the third robot to start moving forward, and 40 is a signal to the third robot to start moving backward. So I'm using 10 and 20. So this first one gives out signals 10 and 20 to tell the second robot to move forward and backward, and the second robot gives out signals 30 and 40 to tell the third robot to move backward or forward. Okay. Now this is for when it reaches the end of the line and it stops. But how does it move? Well, this second, that's where the monitor IR data, infrared data function comes in. Here we are reading the infrared data and put it in a variable. Otherwise you're going to lose it. So once you read this data, it disappears. You have to put it in a variable like y. If y is equal to 10, and that's the 2 values that we are sending, y is equal to 10 or y is equal to 20. If it is 10, means there's a signal from the lead robot, which means start moving forward, and set X equal to 0 means X equals 0 means now this Edison is moving forward. That's what we are checking over here, that once it reaches the end of the line, okay, where are you coming from? Oh yeah, you are moving forward. So I'm gonna now tell the third robot to start moving forward. So that's where X is used to know what is the previous state, what was the state when I reached the end of the line. Otherwise, you have no idea what the state is, right? So X is equal to 0. So now you're moving forward, not yet, but this line that moves you forward, and it plays a beep just This is just for my indication to know that Edison has acknowledged the message. And then it again, just like the leading robot, it moves 5 centimeter forward, and then it starts driving unlimited. When it reaches the back line, y is equal to 20, and this this tells this is the signal from the lead robot telling this robot that you have to start moving backward. It plays the beep, acknowledging it has received. Set x is equal to 1 means now it's going to start driving backward. It drives backward 5 centimeters again, just like the leading robot, and then it drives unlimited. So that's the motion for the second robot. It's sending the data. This is where it's sending the information to the third robot. It has reached the end of the line, sending the information to the third robot to start moving forward or backward, depending on where this robot is coming from. Similarly, if it was going forward, it will tell the third one to start now going forward. If it were going backward, it will tell the third one to start going backward. On here, again, the robot is basically um, getting the information from the lead robot, and if it is 10, it will start moving forward. If it is 20, it will start moving backward, and also set the a variable x to know that, yeah, it was going either forward or backward direction to send the correct IR data to the third robot. Now the third robot is similar to the second robot. It does nothing. Three means no direction. It in the main loop does nothing, but it has registered infrared data and the IR tracker, line tracker, and the infrared tracker and the line tracker. The infrared tracker gets the information from the second robot. If it is 30 means the instruction to this third robot is start moving forward. It sets the x equal to 0. If is 40 means start moving backward means, and then set x equal to 1. So 0 is forward means and 1 is backward. But we are not really using 0 and 1 or that x anywhere, because there is no fourth robot to send the infrared data to. So that's why the end of the line, like if you have reached on the black line, all it does is basically stops the robot, and that's it. But it does not send any information, and that's why your student may have to modify this line for third, fourth, and fifth robots to so that if you want more robots to participate in this Mexican wave. All right, so that would be the end of my discussion about the Mexican wave project for the Edison robot.